Hello friends, this is Somnath Mukhopadhyay from som-itsolutions, and today we are going to discuss about one of the most important design patterns of the Gang of Four book, that is called command design pattern. In command design pattern, we actually encapsulate a request into a full-fledged class object, and then this object can be moved around within the application. Command pattern is also known as the equivalent object-oriented equivalent of the callback mechanism. In callback mechanism in C, we used to have a function pointer, and which basically when called will execute a piece of code. Similarly, in command pattern, whenever the command is being executed, a particular piece of code will be run. So this is why this command pattern is also known as the object-oriented version of the C's function pointer based callback mechanism. In command pattern, there are specific few participants. I would like to discuss about the participants here. First of all, so the first participant in the command pattern is the command itself. Command is nothing but an interface with a single function. Maybe let's name it execute. So command is an interface which is basically serve the purpose of the command. Then we have concrete command, which will be implementing the command interface. So there may be many commands, concrete command objects in the project. Each and every concrete command object will do a specific task. It's a dedicated work, a dedicated task will do a specific dedicated task. Then we have invoker. Invoker is the object that will basically ask the command to be executed. Then we have receiver. The receiver is the person, receiver is the class which will basically have the knowledge how to execute the command, and it is the end receiver. It is the person who will know how to execute the command, in which way it can do the actual work. Then we have the application or the client. The application or the client is nothing but the main application, and it basically creates the concrete command object, and it basically binds the concrete command object with the receiver. So in command pattern, there is no coupling between the invoker or the person who is calling the command and the person, the receiver, who is receiving the command and is executing it. So there is absolutely no coupling between the invoker and the receiver. But the connection is done. The connection is done to the command object itself. So the invoker does not have any knowledge about the receiver, but the command itself stores the information about the receiver. The command not only stores the information about the receiver, but it can also store the information about the state of the state of the class. Okay. So now let's start doing an example. Let's try to understand the command pattern using an example. I have thought of an example of a restaurant system. For example, suppose when somebody orders some menu in the restaurant, then the order goes to the chef. So chef will work in this example. Chef will work as the receiver of the command object. Then we have waiter, which basically asking the chef to execute the task. So waiter will work as the invoker, and then we have the command itself, and then we have the client or the restaurant system itself. Okay, let's start the project. First of all, let me create the receiver or the chef class. Okay, all right, let me start it. So let me create a class called chef. So chef will be the receiver. So it will be the receiver of the command pattern. Okay. So chef will have, say, public void, and then it will say, let's it have prepare food, and when it will prepare food, it will have to depend upon the order or the state of the restaurant, of the customer, okay, or the client, okay. So the prepare food order, so we will have, let's create the order class. Order class, let us create few helping classes like the order and a few others. So let me create those classes first of all. So create class order. So we will create the class order, and order is nothing but a list of item orders each, and you will understand it once I finish this class. So we will have a list, we'll have a list of item order, and item orders equal to new, add a list, new add a list, new add a list, and then we'll have list, and we'll have input list of the details, and then we have add a list. Let's import it, and let's make it private. And so first of all, let's create the class item order. So item order is the class which will basically have the information about which item the customer has ordered, and not only that, how many plates, okay, int number of plates the customer have ordered, okay. So first of all, let's create the item class. Item class is the end class of an item, which is basically having few things like, let's have it like private, and it will have an ID, it will have a name, and it will have a price, okay. It will have a price. This item is a end class, so let's have a getter setter for all the things. So we will have create getter setter for this item ID, then we will have getter setter for all the things, and then we will have getter setter for all this, okay. Then let's create a constructor. So public item, and we will have int ID, string name, price, and let's have a this dot ID, ID. This is, it's pretty simple, right? This dot name, that name, and this dot price equal to price, okay. So these are the helping classes. So there are a few helping classes that I have created. One is the item, and the other is the item order, and the other is the order. So let's create a getter setter for item and number of plates. Create a getter setter of number of plates. Not only that, let's create a constructor, and it will have item, and in number of plates. So let's create it, this dot item is equal to item, and then this dot number of plates, this number of plates is equal to number of plates, okay, cool. So this is done, item order is done. Then let's concentrate on the order class. So we'll get a setter for order class. This is the order. So this is the order. This order class is the order that the customer will create ultimately to pass on to the chef through waiter, okay. Now let's come back. So these are the helper classes, order, item order, and item, which are needed to execute this command design pattern. Let's concentrate on the receiver class, that is the chef. So prepare food will prepare food. So let's have another Another method maybe is public void prepare tea and coffee order. Okay, so this will have, let's have it something like, so item orders, item orders is equal to order dot get item orders, and then what we will have actually, what we will do actually, get item order, what is this, item order, what is this item order, oh okay, right, so chef, so what will item order, so list of item order from the others, let's have a list, add a list of item order, let's add a list of item orders is equal to order dot, let's import it, so item order get order dot get list, we will have at cost, okay, order, and then what we will do actually here, so int, so we will do something like for int I is equal to 0, I less than item orders dot size, item order size I plus plus, or whatever may be the orders, basically prepare it, so we'll have system, so we'll have item, so let's have it something like that, system dot out dot println, and we'll have something like like item orders dot get I dot get I dot get item dot get item, sorry, get I dot get number of plates atho plus plates of plus plus item orders dot get I dot get item dot get name, okay, this plus have been prepared, and then we'll have this way, so this is fantastic. And then after the so each and every item will take some time to prepare, so let's have a thread.sleep, let's emulate it using a thread.sleep 2000 milliseconds, and then we'll have something with surround and try-catch block. So this is exactly the simple way. I know prepared food is a very complicated thing, but let's simulate it here in the project. So what it is doing, we are getting the item orders from the order, and then from each item order we are basically printing out, so this many plates of item orders that that item has been prepared. Okay, and because to prepare it takes some time, so we have done a slip. Okay, similarly here we have, let's copy that and let's have it something like Control V. Only thing is that here cup shop Control S. Okay, cup shop and have been prepared. Okay, this is the, because prepare T and copy public first. So this is the receiver, this is the receiver. Receiver can do two things. One is the, because chef can do only two things, it can either prepare food or it can also prepare tea and coffee. Okay, so these are the two methods the receiver, this receiver or the chef can do. It can prepare food and it can also prepare tea and coffee. Okay, now let's concentrate on the other parts of the command pattern. So let's create a command class. It is an interface. As I told you, command class is an interface. So let's have a command class and it will have an, it's an interface, right? It's an interface, and let's have a method called void execute. Okay, void execute. Let's have a method called void execute. Okay, in the command class we have a method called execute, and then we will have few concrete commands. As I told you in the beginning, each and every request will be converted into a first class object. So let's do that. Let's create few concrete command objects. So let's create new concrete class, and which will basically implement command. All right, and then what we will do actually here, say prepare food command, and let's finish it off. And then what we will do, we get another class called new class, and it will also have command, and then it will have prepare tea and coffee command. Okay, so it will have we will have these two commands. One is the prepare tea and coffee commands, and the other is the prepare food commands. As I told you, this command object will have a reference to the chef. So we'll have a chef or the receiver, chef, and then we have also, we will have a state of the state. We will keep a state of the order. Okay, so we'll have a something like order, because receiver needs this method. Receiver needs this method to prepare the food, right? So prepare the food. See, order, it needs the order object to prepare the food. Okay, so let's concentrate here. So what it will do here actually, so let's have a construction. So we will have public prepare food and command, public prepare food and command. So what we will do actually here, we will do something like we'll create a reference to the receiver, and not only that, also keep the state. So what you will do, this is straightforward, and then what we'll have, this dot order, fail to order. Okay, so this order is order. Similarly, in the execute command, as the command does, it will simply ask the prepare food, and then it will pass the order. Okay, similarly here it will have the same thing here, in the prepare tn command. So we'll have only thing is that prepare tn coffee command, and what we will have here, it is simply called shape dot prepare tn coffee command order. Okay, so this is the command objects. It is not only storing the reference to the receiver, it is also storing the reference to the state. Okay, it is also storing the state. Now what we will do, let's create the invoker class. Invoker class, what I told you, waiter will work as the invoker which will ask the chef to execute the command. So let's create the invoker class called waiter. So let's have a waiter class, and we will have this thing. Waiter will have a private. So what let's have something like in the people food command or a chef. So, okay, so what I will do, waiter private command, and then we'll also have a getter setter method for command, and not only that, we'll have let's have a public waiter command. So waiter will do something like this dot command equal to command is equal to command, and then what it will do, the waiter will simply public void ask chef to execute. Waiter will simply ask the chef to execute the command. So what it will do, actually it is simply command dot execute. See, waiter doesn't have any knowledge of the invoker. Waiter will work as the invoker, right? Waiter will work as the invoker of the command pattern, right? Command pattern. Waiter doesn't have any knowledge about the receiver or the chef. Waiter executes all the receiver the same way. So this simply calls command dot execute. Waiter asks the receiver or the chef for every command the same way. Okay, it has only knowledge about the command, and command has the knowledge about the receiver. So waiter is completely decoupled from the receiver. This is the best part of the solution. The invoker is not coupled with the receiver or the person who is going to handle the command ultimately. Okay, now let's with this scenario, let's try to fix the the client or the main. So main will be working as a client here. Let's have a main. So what we will have in main, well, first of all, chef is equal to new chef. Waiter main will work as a client. Then let's as I told you, the client will create few concrete command objects. So let's have something like prepare food command is equal to new. So because food command needs the order, let's create the order object. So we will have something order prepare food order is equal to new order, and the new order what is the order class? Let's see the order class. It has a order, it has a item order, right? So it should create the item order class object. So item order, and then item order, it will have a okay item order. Okay, so what we will do, actually order will, so let's go to the main, new or new order, and then what we will do actually here, then or prepare food order dot get item orders dot add. Few we will add few item orders, new item order, and then new item. You will have say 1, and then we will have, as it is bread, and it will have say price is $100, and then number of plates maybe say 5. Okay, so we are adding an order, so this is, and then we have prepare food order dot get item orders dot add. So new item order, new item will have set 2, and then salad, and then we have maybe we'll have say $200, and the number of plates maybe say 10. Okay, all right, so we have created few order items, and then let's create the order for prepare tea coffee command. Sorry, prepare. So we'll have order prepare tea and coffee order, new order, and then what we'll do actually here, prepare tea and coffee order dot get item orders dot add new item order item, and then we'll have say 10, and then say tea, and then say maybe the price maybe the say $20, and then we'll have number of plates. We'll have, let's have 5 cups of tea. Okay, let's make 5 cups of tea, and then we have, okay, and then what the next we will do, we'll do prepare tea and coffee order dot get item orders dot add new item order, and then new item, and then we'll have say 11 comma coffee comma say $50, and then comma number of plates maybe say 10. Okay, all right, 10, 11, and this is okay. So we have created 2 orders. One is the food order, and the other is the tea and coffee order. Now let's create the prepare food command. So this order is the state of the client. So what we will do actually, prepare food and command. So new prepare food command, and then we'll have chef, and because this is a food command, so we will have prepare food order, right? We will give this to this, and then what we will do actually, prepare tea and coffee command, tea and coffee command equals to new prepare tea and coffee command, and then save, and then naturally we have to pass this order. Okay, have to pass this order. and then that's it. So we have our order ready, we have our chef ready, we have our command ready. That's it. Okay, so the invoker is the waiter. So when the customer, so here the customer is the main or the client, so maybe it may be a restaurant system. So when the client when the customer creates an order, the waiter simply so let's create a waiter as well. So we'll have create a waiter. So sorry, so we will have, let's get here. So we'll have two waiter food, waiter for food is equal to new waiter as the, so we'll have command, right? So we'll have say food command. Okay, so we'll have food command for the waiter for food, and then we'll have waiter for tea and coffee is equal to new waiter, and then we'll have tea and coffee command. Okay, now the waiter has a command, and the command has the knowledge about the receiver or the chef, what the chef is supposed to do. Okay, now let's waiter for food, and then it will ask the chef to execute the command. Okay, so and then we'll have waiter for tea and coffee, and then ask the chef to execute the command. Okay, so let's run this application. Let's see how it works. Okay, let's see how it works, then we will explain a little more things, and then we will conclude the discussion. Okay, so let's I hope it will work. So this is cancelled. Where is the problem? Chef, what is the chef is doing? What is the problem here? What is saying? So this is okay. So probably. So what I will do actually here. So try and catch. No. So what it is doing here? Order, and then no wrong, right? File, save all. That's it, right? No problem. So let's run it. So 5 plates of bread have been prepared, 10 plates of salad have been prepared, 5 cups of tea have been prepared, and 10 cups of coffee have been prepared. So see, the waiter, the restaurant system is getting the orders from the clients or the customer, and then it is passing. Waiter is simply asking the chef to execute the command or to prepare the food or tea and coffee. This is how the command pattern works. So before we finish, let me before we finish, let me give you the before we finish, let me give you the class diagrams of the command pattern. So this is the class diagrams of the command pattern. As you see, the client, we have a command interface, we have a receiver. The receiver, the concrete command has the reference of a receiver, and not only that, concrete command may have a state. For example, here the command object has a state called order. Right here, the concrete command object has a state called order. This is the order, this is the state. So concrete command not only have the knowledge about the receiver, but it can also have the state of the client. And then what it will do, whenever the invoker will simply also, sorry, I have forgotten the invoker class. So probably invoker will simply I have forwarded the invoker class here, so it will have invoker will simply ask the command to be executed. So it will have a composition, not a composition, it will have an aggregation, it will have an aggregation to the command. Okay, aggregation to the command. So this is how the command, this is how the command pattern class diagram looks like. Invoker will have a reference to the command, and the concrete command object is composed of the receiver object. So concrete command object has reference to the receiver. Not only that, the concrete command object may have a state of the client. For example, here the concrete command object has a state called order, right? So this is and the client creates the concrete command, as well as client creates the receiver, or here the shape, and then the invoker actually basically asks the receiver to execute the command, and then the receiver then the concrete command actually, the receiver dot execute is being called on receiver. This is the class diagram of the command design pattern. I hope it's a bit complicated. I hope I was able to throw some good explanation. I was able to explain it properly and clearly to you. So next time I will explain even some more design pattern as well. So till then, goodbye and have a nice day. Bye.